what we're going to be going over here is a cost volume profit analysis problem. But before we get into the specifics, I want to outline what we're going to be doing here and lay out the numbers that we're going to be using. So specifically, we're going to be calculating the break-even point along with the break-even revenue. And then we're also going to be looking at some targeted operating income here for this problem. And what we're going to lay out here for the numbers here is we're going to be looking at this cost, laid out here in this cost volume profit graph here, where we're going to have our units sold is going to be our x-axis, and that's going to be from 0 to 200 for this problem here. And then along our y-axis, those are going to represent our dollars here, either costing dollars or revenue dollars. So what we're going to do for this break-even point here, this is where our revenues line, and I'm going to have that laid out here, it's laid out in blue, is going to intersect with our costing line here. So where they intersect, that's where we're going to have this break-even point where our revenues equal our costs here. Okay, so for our revenues, that's going to be based on a selling price here of $50 per unit, and our cost, that's we're going to have, along with the cost here, we're going to start out with a fixed cost here of $2,000 for this problem, and that's going to be a constant cost here over the numbers or the units that we sold. So that cost isn't going to increase the fixed cost. How many units you sell here, fixed cost is going to remain here at $2,000. And then along with our cost, we're going to have a variable cost here at $30 per unit. So our costing line here is going to start out at the $2,000 fixed cost amount, and it's going to move up here at $30 per unit. So at some point, this revenues line here is going to intersect with our costing line, and that's what we're going to have to determine. So the key is here, when you're looking at this break-even point here, the point is anything below the break-even point, you're going to be operating at a loss here. Anything above the break-even point, you're going to be operating at a profit. And the key is here, well, of course, when you sell 0 units here, you have 0 revenues coming. You have 0 revenues because you don't have any revenue coming in here. But as you move up the line, then you're going to have more revenues. But at the same time, your losses here are it's going to taper down here, because your cost line here is only at $30 per unit, whereas your revenues here is increasing at $50 per unit. So loss is going to be narrowing down to our break-even point here at 0. So greater loss, lesser units sold. Now, once you get over this break-even point, then just the opposite happens. So the more units you sell, obviously, the greater profit you're going to have. Again, just looking at the slopes of the lines here. Revenue is at $50 per unit here. Cost is at $30 per unit, but we've got that fixed cost built in here. Okay, so that's the idea of what's going to be going on here. Now, let's go up and let's look at the basic equation that we're going to be using here. So we're going to be concentrating on this operating income equation here. Again, this cost volume profit equation here that we're going to be looking at. And this is where you're going to be, this equation here is going to determine the operating income. So what you're going to be doing here, you're going to have your selling price here minus the variable cost here, that quantity times the quantity sold. And that's what we're going to have to determine, the quantity sold. Then you take whatever amount you get here, your selling price minus variable cost times your quantity sold, then you have to subtract out your fixed cost here, and that's going to equal your operating income. And then the other point is the selling price minus your variable cost, that really is represented as your contribution margin per unit. So what we're going to do with the equation here, this operating income, to determine the break-even point, we're going to set that equal to 0. That's where our costs equals our revenues here. And then for our targeted operating income, we're going to set it at some value here to determine what quantity we'd have to sell it at, or the quantity that we'd have to sell here, and also the revenue that would be coming off, the profit that would be coming off it. Okay, so now let's move on to the problem itself. Now we're going to be looking at calculating what they call the break-even point here, and we're also going to expand that into calculating what they call some targeted operating income or some profit here. So starting with our break-even point, and really we're going to be going through a number of different methods here to understand this break-even point and how you calculate it here, but each of the methods are going to involve the same assumptions here. So when we're talking about this break-even point, that's really the point here, and we're looking at it on our cost volume profit graph here. That's the point here where our revenues that we receive here are going to equal our costs here, and that's going to be based on some units sold here. So we're going to have to calculate the number of units sold to determine this break-even point, and based on those number of units sold, then we can determine the revenues or costs. And in this case, since we're talking about a break-even point, our revenues here are going to equal our costs. So what we have to start with here, and looking at it on our graph here, again, our units sold is our x-axis here, and they increase here, and for our example from 0 to 200 here. And then on our y-axis here, those are our dollars, either our costing dollars or our revenues here. But what we have to start with here when we look at this break-even point, this is the case here where I'm going to be showing here, I got it in blue here, that's going to be our revenues line here, and that really starts at 0 here. In this case, you're going to, we're using the case here where we're $50 per unit we're going to get in revenues, or that's going to be the selling price. So as you increase here the number of units sold, your revenue is going to increase by $50 times those number of units sold. And what we're talking about with break-even point, our revenues line here is a steeper slope, and it's going to increase faster than our cost line here. But the fact is, when we're talking about costing here, we don't start out at 0, we start out at, in this case, $2,000, the fixed cost. So the fixed cost is constant over our units sold here, but when we get up into what we call here for our costing, we're going to have to add in variable costs, and in this case it's going to be $30 per unit, the variable cost. But nonetheless here, you looked at our revenue here, we started out at 0, and that would be our revenues or our income that we're getting here. But when we start with our costing for those units sold, we have to start at $2,000. We have to start we have to start at the point here based on those fixed costs. So with our costing line here, we're only going up at $30 per unit, but we started out at $2,000. It has a less of a slope here than our revenues line, so it's going to intersect at some point here. Our revenues are going to equal our cost at that point. So that's what we want to go and we want to calculate. Okay, so we got several different means of looking at that. So let's start out with our first with our equation here, our operating income equation here that we looked at before. But this is the case here where your revenues are going to equal your costs. So what we do is we set that equation equal to 0. So I've got it looking at it here. So that's going to be our first means here. Now that equation is really our selling price minus our variable cost, and that quantity or that difference here times the quantity sold. So we have to determine the quantity sold. But taking that difference here, and I factor it out. This equation here, I factored out the quantity sold already from our selling price and our variable cost. But taking the difference here, selling price times our variable cost times the quantity sold, we have to subtract out those fixed costs. Okay, so just looking at our example here, selling price minus our variable cost times our quantity sold minus the fixed cost has to equal 0 in this case, but we're looking for that break-even point. So this is where we're not going to have any revenue. We're going to have a 0 profit essentially at that point. So here, plugging our numbers in, $50 selling price, fixed cost $30, and then that would be times our quantity, subtracting 2,000 from it. Again, 2,000 fixed cost here. So we come up with, we want to set that to 0. So now what we would do here, just subtracting $50 from 30, we're going to come up with $20 here times our quantity. That's going to be, we're going to subtract or add 2,000 to both sides here to move this 2,000 over to the other side of the equation. So we get $20. The difference here times the quantity equals $2,000. So quantity here, just divide both sides of the equation by $20 here, and you're going to get the quantity equal to $2,000 divided by $20 here. That happens to be the contribution margin. That's going to equal 100. So that's our break-even point here. 100 units have to be sold to break even. So we're not going to have any income at that point here. This is going to be the break-even between our costs and our revenues. Okay, so then our selling price. Okay, so we've determined the number of units we have to have sold here, 100 units. Now for our selling price, really simple here. Just to break even revenue, that would be taking your selling price here, $50, times the quantity, the break-even quantity here of 100 that we calculated. That's going to give us our break-even revenue here of $5,000. So this $5,000 here really represents our revenue that we would have received here, and it also represents our cost. So the break-even point is 0. Revenues minus costs would be 0 at that point. Okay, so the second means we could look at here, we'll just look at it in terms of these line equations that we have. We're going to have an equation, there's a linear equation because these are straight lines. We're going to have an equation here for our revenue line here and an equation here for our cost line. And that's really we look at the slope here. Revenue, we have to determine the slope of our revenue lines, and that happens to be $50 that we talked about here. And then the slope of our cost line, that has to be $30 here. But plugging those numbers into our line equation here, where y equals m, the slope here, times that quantity that we have to determine here, plus whatever b is. And b is the y-intercept here in our equation. So that's what we're going to be looking at here. M, slope, and slope for our revenues line is going to be 50 here, and in the b or the y-intercept here, where it crosses the y-axis here for our revenues line, is actually 0, so we don't have any b-intercept. But when we talk about our costing line here, well, we have a slope of $30 per unit here, or slope of 30 times that quantity that we're going to have to determine here. But we're going to have a b-intercept at $2,000. Okay, so let's go and look at how we determine our quantity here based on our setting our line equation. Revenues equal our cost, or whatever. Essentially here we'll be looking at y here and comparing both of those line equations. So let's go down and look at that here. Okay, line equations here, revenues equals cost. Again, remember that was the y-intercept here for both our revenues and our cost, and that's going to be some dollars here where our our lines are equal. Our revenues are going to equal our costs. And again, a line equation was that m here, the slope, times the quantity here, plus whatever the intercept was here. Okay, so for our revenues, remember our line equation was slope was 50 times the quantity. We're trying to solve for the quantity here. That revenues line here is going to equal the cost line here, where we got the variable cost here of $30 per unit times Q here. Again, Q here is the quantity we have to solve for, but we have to add in that fixed cost here of $2,000. That's the where the b-intercept, or where that line starts here, the variable costs start here at $2,000, the fixed cost. So just solving our equation here, moving our $30, adding or subtracting 30 from each side here, we're going to get the $50 revenue less our $30 cost times our quantity. We just moved these number, the $30, the variable amount, over to the left-hand side here, to our revenue side. So just simple arithmetic or algebra here. Now that is going to equal $2,000 here with rearranging that equation. So now just taking our 50 minus our 30 here, we get $20 here. Actually, that's the contribution margin, as they'd call it here, times our quantity, again equal to 2,000, and then our quantity here, just divide each side by $20 here. You're going to get a quantity here of $100. So what we did here in this equation here, this X amount here in our equation here, our line equation, that really equates to our Q amount, or the quantity that we had to solve for. So our break-even point here, this is where we looked at those line intersections. Okay, so that's based on the line equation itself. Now let's go up here again. So our break-even revenue here, again, based on our line equation, same amount here. That $50 selling price times the quantity of 100, $5,000. So in both cases here, we are able to determine the break-even point here for the units sold to be 100, and then our break-even point here for revenues or costs, here as you want to look at it, would be $5,000. Okay, so now we really have one other thing we can look at here, and let's look at it in terms of the contribution margin that I mentioned here. Contribution margin, that's simply the selling price minus our variable cost here. Now, what we would do in this case, we take it times the quantity sold, contribution margin, but we take whatever we have, that amount here, we'd have to subtract out our fixed cost again, and again, because we're solving for the break-even point here, we'd set that equal to 0 here. So that's really our operating income equation here from the equation point. So just looking at our selling price minus our variable cost times the quantity here. This is what we're solving for, the quantity here, minus our fixed cost here. We set all that equal to 0 here. So just solving it here, $50 for the selling price, variable cost 30 again, times our quantity, and then subtract out the $2,000 fixed cost equal to 0, and just rearranging our equation here, making our netting our $30, subtracting our 30 here from our 50, we're going to get $20 here, times quantity again we're solving for equals we move 2,000 over to this side of the equation here, so we get $2,000. So our quantity here is going to equal well, we just divide both sides here by 20. So quantity here equals $2,000 here divided by 20. Again, it equals that 100 units sold here that we calculated up above for both of the other cases. But now just expanding on that here, we're going to look at calculating our break-even revenue here based on this contribution margin. So for our contribution margin here, this is the equation we use here. So we take our contribution margin divided by the selling price here to determine the contribution margin percentage here. So contribution margin, again, was our selling price minus our variable cost. And dividing all that here by our selling price, well, we had a selling price of 50 minus our variable cost here 30. That quantity, net amount here 20, divided by the $50 selling price here, we're going to get a contribution margin percentage here of 40%. So now we can go and calculating our break-even revenue based on that contribution margin. So again, we just have the fixed cost here of $2,000, and then we would divide it by that contribution margin percentage of 40% here. And it's essentially this $20, it's just substituting the 40% in here for this $20 here. Now we come up with the break-even revenue, and that's based on that quantity sold here, 100 units here. So break-even revenue, $5,000. Same as we calculated up above here using our equation here where we had our selling price and our variable cost. I'm just showing it in terms of the contribution margin here, and then we resolve to determine our break-even revenue. We had to determine our contribution margin percentage, and then based on that, again, we were able to determine our break-even revenue. Okay, so that's for our break-even point here and our break-even revenue. Now let's go up here and let's look at the case here where it ties in with what they call some targeted operating income here, and we're going to set that equal to $1,400. So essentially we want to find some quantity here, units sold, where we can earn $1,400 in our example here, and that is really some point here where we're looking at our revenues less our cost is going to equal that targeting operating income or profit here. So what we do here, same thing as we did for determining our break-even point here, where we set we had to determine our income versus our costs here, where they were equal. That was the break-even point. So now what we're going to do, we're going to use this equation that we have up here that we went through before, and we're going to set it, instead of setting it equal to 0 here for the break-even point, we're going to set it equal to $1,400. That's going to be what we call our targeted operating income again. Okay, so what we would do here, again, using that equation, our selling price here minus our variable cost times our quantity here, minus that fixed cost again. In this case, it's going to have to equal the targeted income here of $1,400. So plugging our numbers in, 50 here for selling price, variable cost of 30. Now we have to solve for that quantity here, the quantity of units that have to be sold here to determine this $1,400. But from that amount here, we have to subtract out the $2,000 fixed cost, and that all has to equal $1,400. So what we would do, just rearranging our equation here, move the add 2,000 to both sides here. That removes, actually you're just moving the 2,000 over here from the left side to the right side of the equation here. So you get 1,400 plus 2,000 equals $3,400, and then our selling price minus variable cost, that's $20 times the quantity here. We're solving for that quantity. So again, just solving our equation here, dividing $20 into both sides, that leaves our quantity here is equal to the $3,400 here divided by $20, which equals 170, a quantity here of 170. So to earn $1,400 here in profit, or what they call target operating income here, we had to sell 170 units. And okay, just looking at our graph here again looking at our profit line here, I'm just calling it total revenues here. That's going to be at that 107 units sold here of 170, and then our profit, same thing here. That's our total cost line here. We're showing that here. Total revenue here I'm showing as our total revenues. That was the revenues that we earned here on those that's the total the revenues received on the sales that we made here. And then our total cost line, that was, again, remember, that was our fixed cost. We start out our total cost, variable cost here. First, we have to include that $2,000 fixed cost, and then moving it up here, it happened to be at $30 per unit variable cost. So determining our profit here, just to cross-check what we've done here, based on that quantity I had to determine here at $170 to earn $1,400. Our total revenue, again, would have been $50 selling price times the quantity, 170. That's going to equal $8,500. So that's our total revenue here. Now, moving down to our total cost, that was the variable cost here, $30 times that quantity we calculated here at 170. But we had to add in the variable cost here at $2,000. So that all equates to $7,100. So now we can determine our profit here based on total revenues here. We determine that to be $8,500 and subtract out our total cost here of $7,100. So there we're going to get, the difference gives us that profit here of $1,400. So that's just looking at our graph here, that's just the cross-checking here based on that $1,400 targeted operating income we looked at. So our profit here, looking at it from the terms here of our revenues here versus our cost here, subtracting our total revenues here that we had at that $170 or 170 units sold, the 8,500, subtracting our total cost here for those 170 units here of $7,100. The difference gives us a profit here of $1,400. So that's what we're talking about, targeted operating income or profits here. Just to make a point here, again, when we're talking about these break-even points here, didn't mention it earlier here, but you can see here when you're talking about the break-even point here, you're really looking at where your loss here. You started in at a greater loss here with 0 units sold, and because you have that fixed cost that has to be figured in when you're talking about your total cost here. And as you move up and you sell more units here, your loss is going to be lesser and lesser on a per unit basis here. and then you meet that break-even point here, and then beyond the break, so below the break, any quantities below that break-even point, we calculated that to be 100 units in this case, we actually have a loss. But any quantities that are sold beyond our break-even point, we're going to have a profit, or we're going to have some profit on those sales here, based on our line equation, our lines here, our total cost versus our total revenues. And then as you move up here, you sell more units, you're going to have a greater profit here. And the only point is, when we're looking at these lines here, we have to figure what the line equation is, or the slope would be in those lines. But when you're talking about total cost here, you have to start out at the point here where you have to cover your fixed costs first. In this case, it was $2,000. So that's where our total cost line is going to start out on a per unit basis. So 0 units sold, you still have to you're still going to have a total cost here of $2,000. And because our variable cost beyond the $2,000 fixed cost here, variable cost is going up at $30 per unit, whereas our revenues here, even though we started out at 0 here, because you get $0 for there was no units sold, you get $0, but our revenues here is going up at $50 per unit here, so the slope, or it's increasing at a greater rate here, but then we get to that break-even point. And then remember, below the break-even point, that was at 100 units sold here, we actually had a loss, but our loss was narrowing or lesser of a loss here as we move up to the break-even point. But then when we go beyond that break-even point, say that 100 units here, when we increase it to 120, 130, 140, we're going to have a greater profit here. And that's what they're really looking at when we're talking about this cost volume profit graphs here, or equations. So I guess that'll summarize what we're talking about here. All right, so that'll conclude it.